Welcome to Lesson 31. So we're going to talk about the robustness of T procedures. So the idea is when we use T methods, how reliable can we really view our results as? So the idea of robustness is the outcome of a test. It's still being valid even if you don't meet all of the conditions. So not meeting the conditions doesn't mean that you should just throw it all out. It's still a fairly reliable test if it's very robust. So small sample sizes though, those are really problematic. The t-tests really don't do as well if you have a very small sample size, especially if that sample is very skewed or you have outliers. So we say a lot of the time, as long as our sample size is big enough. And so we want to clarify, what do we mean by that? So really it's important that we have a representative sample, that our sample reasonably looks like the population does. The easiest way is to use a random sample. But then here, so if my sample sizes are smaller than 15, the population needs to appear roughly normally distributed. So it needs to be, roughly symmetric, one peak, no big outliers, definitely not looking at skewed. Less than 15, you really need the population to look pretty good. If you increase it a little bit, so 15 to 29 or so, and it's not like hard, like if it's 29, it's definitely not big enough. But you're not going to want to have extreme outliers or really strong skewedness. So some mild skewedness is okay. If it's very strong skewedness, it's really not going to be okay. So this is kind of like a medium size. So samples of 15 or less than 15, you're going to really want to have a population that's roughly normal. Versus, hey, it doesn't have to be perfectly normal if you take a bigger sample size. And then our rule of thumb, if it's at least 30 and you're testing or estimating a mean, it's going to be okay. So the T procedures, they can pretty much be used anytime that you have sample sizes of 30 or more. Just know that if you have a medium or smaller sample, you're going to have to know something about the population, like, oh, it's roughly symmetric, or oh, it's very skewed, oh, it's not going to work, that kind of idea. Okay, so just a couple of examples. So the first one, we are going to go ahead, we have a population that's roughly normally distributed, and it's centered at 8, and we're going to go ahead and we're going to take a random sample here. So I took a random sample of 14. Honestly, it looks like it's centered roughly at 8, but it's going to be okay. Having this smaller sample size, so like 1 to 15, please don't take a sample of 1. That's really just too small. This is going to work out okay. So looking here, if I wanted to test, hey, mu is equal to 8, we really don't want to reject this because we know that the mean of the population actually is 8 because we're simulating this. So I know this looks all complicated, what it comes down to is when we simulate this 1,000 times and we run like a hypothesis every time, and we look at, how many times do we reject it when we shouldn't, which is every time we reject it because it's actually 8. My type 1 error is equal to alpha. So whatever you set it to is what the type 1 error rate is. That's what you want. You don't want your type 1 error rate to be something other than what you set it to be, because then you can't predict how often you're making this error. It makes us very sad. So in contrast, here is an example where we are going to draw from a very skewed. So this is a right tail, so this is a right skewed population, right? And it's very strongly skewed. So it's a mean of 2, but very, very skewed. So if I take a sample of 14 here, so remember 14 is not very big, this looks pretty skewed. This is not going to be probably the best. It's not going to work out in the long run. It's not going to have reliable results if you're taking small sample sizes from a population that looks like that. So looking here, if you want to test, okay, well the mean is equal to 2, we know that it actually is in fact 2, so anytime that you actually reject the null, you're incorrectly rejecting, you're making a type 1 error. So now what you have to worry about is when we simulate this 10,000 times, instead of rejecting incorrectly like 5% of the time, now we're rejecting 7.8% of the time. So our type 1 error rate has increased. We're rejecting too often. So basically, if our sample size is too small, and we're drawing from a population that isn't nice and normal, we're gonna have problems. We're not gonna have reliable results. The key is please try and make sure that our sample size is big enough. So we're on to the year turn. I strongly recommend giving these a shot. Definitely some really solid practice. I also posted some extra practice problems that are posted on the lecture page, the lecture materials page. So please check those out, and I look forward to hopefully talking with some of y'all on the discussion board.